Hi guys, welcome to chapter 8. We're going to learn all about volcanoes in this chapter. Kind of cool stuff, all right? So let's talk about the basic parts of a volcano. This diagram includes most of them. We might talk about some other ones. Volcanoes are basically just like mountains that explode, okay? They're mountains that contain magma, but they've also been built by the cooling magma. A volcano can continue to grow as it erupts, okay? And it's named after one of the gods that we, talk about in mythology. It's not somebody that we actually believe in being Christians, but Vulcan was the god of fire, and so that's why volcanoes got their name, okay? The word igneous, we're going to talk a lot about igneous rock. We've been talking about sedimentary rock, but now we're going to talk about igneous rock a little bit. That just means it had to do with molten material, okay? So once the molten material, once that magma solidifies into rock, that's known as igneous rock, all right? Okay, so let's start talking about some of the parts. We've got the vent of the volcano, and that's the actual opening, okay? That's this right here. The hole that the magma comes out of is the vent, right? Once the magma hits the surface of the earth, it's then called lava, okay? So it's magma down here, and it's lava out here, okay? So once it exits that vent, it's called lava. It's the same stuff. It starts to cool once it comes out to the surface, but it's the same stuff. It's that same molten material. The crater is the shape of the mountain, okay? So kind of the depression that forms right here, if there was no lava there, that would be the crater. The vent is the actual opening, and the crater is just kind of the shape of the top of the cone, okay? And then if you have a really big volcano that's erupted and maybe collapsed or just completely blown off, it might leave a really large depression, and that's known as a caldera. I'll show you a picture later in this chapter of Crater Lake in Oregon, and that's actually a huge caldera from a volcano that's filled in with water and it's become a lake, okay? I also want you to know about these side vents. So sometimes the lava comes out of the side. This conduit is often called a pipe or a neck. And there's a lot of geographical formations that come when the magma inside of those regions of the volcano actually cool. And then the last one down here, you can't see the whole word, but the magma chamber, okay? So there has to be a supply of magma for these volcanoes to erupt. And a lot of times it's even deeper than what this diagram shows. And you've just got this big collection of magma down there, okay? And what it's doing is it's looking for an opening, okay? Think about a can of soda. If you shake it up, it's inside. It's not going to go anywhere, but as soon as you crack it, it's going to start shooting out. And the same thing with this magma, okay? It wants to get out. It's under a lot of pressure because it's hot. We'll talk about why else in just a second. But it wants to get out. So it's looking for openings. It's constantly pushing on the mountain, which could actually weaken the mountain, okay, and form cracks of its own, okay? All right, so volcanoes could put out liquid. So liquid emissions is the lava that comes out. Most of the volcanoes emit lava at some point. There's different types of eruptions. There's solid eruptions we'll talk about in a minute, but most volcanoes at some point will actually spew out lava, okay? Excuse me, there's three main types of magma that we're going to talk about. Remember, it becomes lava when it comes out to the surface. The amount of silica that's in the magma determines what kind of magma it is. Silica is just a combination of silicon and oxygen, two of the elements on the periodic table. Excuse me. And the more silica there is in the magma, the thicker it is, the more viscous it is, okay? So we've got rhyolitic magma, we've got andesitic magma, and then we've got basaltic magma, okay? Rhyolitic has the most silica, so it is the thickest. And when it cools, it actually forms a rock with kind of a light color. If you turn to page 177 in your book, you can actually see pictures of these rocks, okay? The andesitic is kind of the medium amount of silica. When it cools, it's much darker than the rhyolitic rock, but not as dark as basalt. The basaltic magma is the most common. Okay, it forms basalt, which is the most common form of volcanic rock we see. But it actually has the least amount of silica, and therefore it's the least viscous of the lavas. Okay. Once the lava cools, it forms these different formations. Okay, you can see very different looking structures here. We've got this kind of wavy, stringy looking stuff, and we've got this really gnarly, kind of choppy, sharp stuff. Okay, well, that's formed from different types of lava. The top one is formed from a kind of lava called Paoeoe. It's a Hawaiian name, Paoeoe. And it's a very fast moving lava because it's thinner, it's not as viscous. Okay. And when it cools, it's very smooth like that. The second one is A'a. Okay, also a Hawaiian word. Hawaiian words don't always use consonants. So it's AA, but it's pronounced A'a. And it's a much slower moving lava. It's much more viscous. It's a lot thicker. And when it cools, it forms these really sharp rocks. This is actually, I took that picture from volcanic rock in Arizona, Sunset Volcano in Arizona. Okay. And then finally, what I don't have pictured here, but you can see on page 178 of your books, is pillow lava. And that's lava that forms underground. There's a lot of underwater volcanoes. The Hawaiian Islands are spewing lava underwater. And that lava cools very quickly underwater, and it immediately forms kind of a skin on the outside of it. It's still molten underneath, but these skins look kind of like pillows. So it's called pillow lava. All right, we also get these gaseous and solid eruptions, okay, where they emit gases and solid material, not the liquid lava, okay? Back to that idea of the Coke can or a Coke bottle. The reason a soda bottle, after you shake it, the reason it explodes when you open it is because the soda contains dissolved carbon dioxide. Well, magma contains a lot of dissolved gases in it, and so it's kind of like a shaken bottle. And as soon as you take the top off, it just starts spewing out. That gas comes out of the liquid again. Okay. This is what's known as a pyroclastic flow. And it's a very fast eruption. It's kind of like the mountain explodes. Okay. And it brings with it this mixture of ash, all these solid particles, rocks, but all kinds of hot gases as well. There might be some lava actually coming out underneath that's not as visible, but mostly it's just this hot gas and ash that comes out. Okay, still a very high temperature. These eruptions are actually much more dangerous because they're so fast. The lava moves pretty slowly, and it damages buildings, but it's easier to get away from. Okay, the solids are like I said, ash, cinders, rocks, and these things called bombs. And basically, that's just the bigger pieces of rock. I think anything past like baseball size is called a bomb. But some of those chunks of rock can be as big as like small cars. Okay, lots of damage. Something that can happen with these gaseous explosions, these pyroclastic flows, is something called a lahar. Okay, because it's a high temperature, if this volcano was covered in snow, that snow is going to melt very quickly, and it's going to mix with all this volcanic ash that's settling. And it causes really, really big mud flows. Okay, if you see video of the Mount St. Helens eruption, the rivers were filled with downed trees from all these lahars, the mud flows, and the rivers just looked like mud. It was terrible, and a lot of damage from that. Okay, you can also have these things called fumaroles. Fumaroles. These are little kind of side vents that leak gases. So it's not the main vent of the volcano, but it's kind of stuff out on the side, maybe a little bit of a distance from the main part of the volcano itself. That can actually be used as a sign of a impending eruption. Okay, there's actually some fumaroles in Yellowstone, so much so that there's an area called Death Gulch in Yellowstone, and it emits carbon dioxide. Okay, well, carbon dioxide replaces oxygen. If we don't have enough oxygen and we have too much carbon dioxide, we'll suffocate. Okay, well, carbon dioxide is denser than oxygen, and so it settles on the ground. And so this Death Gulch fills with carbon dioxide. And if animals wander into it, they can actually die because they're not going to get the oxygen. Wild. Finally, we've got tephra. Tephra is just the proper terminology for the loose solids that come out, the pyroclastic materials, okay? The tephra, the amount of tephra is going to be talked about a little bit later on how we kind of rate these volcanoes, okay? All right, so where do these happen? Most volcanoes occur at plate boundaries, and that should make sense. Remember, the plate boundaries are like cracks in the crust, and we've got the mantle underneath. That's where the magma is coming from. So anywhere there's a crack, it stands to reason that it's going to be easier for the magma to come out of it, okay? One particular plate, this is the Pacific Ocean here. You can see this kind of ring of volcanoes that follows that plate boundary around the Pacific plate there. That's known as the Ring of Fire because there are so many volcanoes in that region. We've got, here's the West Coast. This is like Oregon and Washington area. And then, like over Japan in this area along down there. Right here in the middle is Hawaii. Okay, it has nothing to do with the plate boundaries. That's known as a hot spot. And sometimes we get these random volcanoes that aren't near boundaries at all. Just sometimes the magma is able to work its way up, and they can occur at these areas known as hot spots as well. Okay. The last little bit of volcano geography is this layer of rock known as a flood basalt. And it's very thick layers of igneous rock. A lot of it is the actual basalt rock. The old Earth geologists think that probably formed when the supercontinent Pangaea was breaking apart. Flood scientists think that the continents were breaking apart as a result of the flood. And there were a lot of volcanic eruptions that occurred during the flood and shortly after the flood. And so flood scientists think that those flood basalts came during that just high activity, kind of tumultuous time. The layers are too thick. It's too much igneous rock just to be accounted for by individual eruptions. It's kind of evidence that something massive was going on, okay? And again, we attribute that to the flood, okay? All right, that's it for section A. See you guys later.